Now first we will learn a bit about resistance. It is a passive element, that is, it is not capable of generating its own energy. So what is the behavior of this resistance? Okay, so first of all, it is represented like this. This is the representation of a resistance, and the symbol that we use is R. Resistance is represented by R. And what about the units? The units of resistance are ohms. Okay, it is represented by this symbol. What is resistance? It is the opposition that is offered to the flow of current. Opposition offered to current, as simple as that. Okay, now what does the resistance depend upon? So every conductor will have its own resistance depending on lot of factors. So what are these factors? R is given by rho L by A. Okay, so what is rho here? This is called as the resistivity. It depends on the material that is used. Okay, it is a characteristic of material. So if you are using copper, there's going to be one value of rho. If you are using aluminium, then there's going to be a different resistivity. Okay, so it will depend on the material that is used. What about L? This is length of the conductor, and A is the area of cross section. Okay, so that means if this is the conductor and the current is flowing in this direction, okay, so the direction of current is important, then what will be the area of cross section? This is going to be the area of cross section. Okay, so the current direction is perpendicular to the area of cross section. Okay, so you can write this is A and the length is in the direction in which the current is flowing. This point is important. Okay, sometimes what happens is we deal with different kinds of currents in power systems. If you consider the cables, underground cables, there's going to be a conductor at the center and there's going to be an insulator. Okay, and we will be dealing with what? The leakage current. So leakage current direction will be like this. In this kind of scenario, what will be the area of cross section? The area of cross section will be the cylindrical area. That means if you are taking like this, then the current is flowing in this direction. So area of cross section is going to be the surface area of this smaller cylinder, elementary cylinder, whatever you're taking. Okay, so that is why it's important to keep in mind what is the direction of current, and accordingly you have to choose the area of cross section and the length. So this is about the expression of resistance. It not only depends on the characteristic of material but also on the physical dimensions, length and area of cross section. Next, what about the VI characteristics? I want you to get familiar with this term, VI characteristics. Why? Because you're going to see it in other subjects as well, especially in analog electronics. What is the VI characteristics? It is nothing but what is the relationship between the voltage across that element and the current passing through it. Alright, as simple as that. So, example, here you have resistance. Now the voltage across this is V and the current through this is I. What is the relationship between this V and I? Okay, so this relationship, it is given by what we call as Ohm's law, right? So this is one of the basic laws in circuit theory, Ohm's law. It is named after the scientist Ohm. Okay, so what does Ohm's law state? It states that the voltage across the conductor, it is proportional to the current that is passing through it. Okay, so conductors satisfy the Ohm's law. Okay, that means for a conductor, the voltage across it will be proportional to the current that is passing through it. Okay, so this is the actual form of Ohm's law. Now if you want to write the equality sign, then you will need a constant of proportionality, right? So that constant of proportionality is nothing but the resistance. So when you convert the proportional symbol into equal to, then you will have a constant of proportionality. Okay, so this is nothing but resistance. for the conductor, constant of proportionality for the conductor. Now if you draw graphically, okay, so let us take this as V and this as I. Sometimes you can find in textbooks that here current will be represented, here voltage will be represented, okay, but for now we are taking V on the y-axis. So Y you will learn now. So the line will pass through the origin. Now what will be the slope here? Slope is equal to V by I, which is nothing but the resistance. If you take I by V, that means if current is here and here it is voltage, then what will slope? What will be slope? It will be 1 by R. Okay, so be careful of what you write in this axis. Now one more important point that you may want to remember here is that you can see that the slope is constant, right? It is a constant value which is given by resistance. For some circuit elements, in electronics especially, there is going to be a variable slope, okay, but for now, for the conductor, we will be mostly dealing with constant resistance only, so you don't have to worry yet about that, okay. Now two of the extreme conditions of resistance, what are they? The first condition is R is equal to 0, that means there is no resistance, there is no opposition to the flow of current, no resistance or opposition to flow of current, okay. So this condition is called as short circuit, and if it is a short circuit, then the voltage will be 0. Why it will be 0? Because if resistance is 0, that means there is no resistance to flow of current, okay. That means do you have to do any work? If there is no resistance, you don't have to do any work, right? So if you don't have to do any work, then voltage will simply become 0, because voltage is nothing but the work that needs to be done to move the charges, right? The current, however, the value cannot be determined. It will be dependent on the circuit in which it is placed, okay, dependent on the circuit, but voltage is going to be 0 if resistance is 0. Now what is the other extreme condition? You can guess. If R is 0 is one extreme, then R is equal to infinity is the other extreme. This means that there is infinite opposition to flow of current. So in such a case, it simply means that it is an open circuit. There is no path for the current to flow, okay. So that's why we call it as open circuit. And when there is an open circuit, there is no path for the current to flow. Obviously it means that the current is going to be 0. What about voltage? This is going to be dependent on the circuit in whichever it is connected, okay. Now the power dissipated by resistor. So this is nothing but the power that is absorbed by the resistor, okay. Usually it will be given out in terms of heat energy. Resistance will give out some heat energy, okay. So it will account as a loss. So if this is the resistance R, the voltage across this is V and I is flowing like this, then what is the power that is absorbed? P, we know that it is V into I, instantaneous power. Now by Ohm's law, if you substitute V is equal to IR, then what you are going to get? I square into R. But if on the other hand, if you substitute I is equal to V by R, then you are going to get V square by R, okay. So remember, this is the instantaneous value of power, okay. But for now, we will discuss only the DC values. AC we will discuss a little while later. So for a DC value, instantaneous value is nothing but the particular constant at that point of time. So you don't have to worry basically, okay. Then what about the work done? This is the power dissipated by the resistor. What about the work done or the energy that is lost? You can take it as energy lost. Integral P dt, integration of the power, right? So you are going to get I square R into T or V square T by R, okay. So here you don't have to worry about the initial values or something. The work for a resistor, there is no storage, so you don't have any initial values, okay. So simply I square RT or V square T by R. So I've told you that resistance is a constant value, but it is going to depend on temperature. Okay, and why is this important for us? Because like I said, resistance is going to dissipate energy in the form of heat, and if heat is generated, then there's going to be a increase in temperature and there's going to be a change in the resistance value. So we need to see what is the change of resistance with respect to temperature. Okay, so let us take two temperatures. There's a temperature rise from T1 to T2, let us say. Okay, or it can be a fall also, temperature fall as well. You can take anything. Now let our T1 will be the resistance at temperature T1 and our T2 be the resistance at temperature T2. Okay, then our T2 is given by our T1 into 1 plus alpha delta T. So what is alpha here? Where alpha is the temperature coefficient. This is going to depend on the material. Okay, and what is delta T? This is the temperature difference. Since we want from T1 to T2, so T2 minus T1 you have to write. If the temperature is from T2 to T1, then it is going to be T1 minus T2. Okay, or you can, more easily you can remember it as T final minus T initial. Okay, so that is the delta T, and this is the expression for finding out the change in resistance. Finally, one last point about resistance is its inverse. The inverse of resistance is called as the conductance. While resistance will give you an idea of how much resistance there is, the conductance, since it is the inverse of resistance, it shows you the ease with which a conductor can conduct. Okay, so this is given by conductance. The symbol is G, and this is given by 1 by R, and 1 by R is nothing but the current by the voltage. And what about the unit? There are two units that we use in practice. The first one is called mho. Okay, so it is the inverse of ohms. Okay, just invert it. Or it is also called as Siemens, and the unit was capital S. Okay, if it is small s, then it is seconds, that is the unit of time. For conductance, the capital S is used for its units.